So now let me explain to you a little bit about today. And I have to do that by telling a little story. A number of years ago in San Francisco, they considered the process of adding fluoride to the water supply. And this was kind of controversial because this was, maybe 20, 30 years ago. And they wanted to know if putting a carcinogen in the water supply was going to benefit the little children's teeth. And they asked the University of Berkeley dean to host a meeting where they would discuss the various issues and aspects of fluoridation of the water supply and bring together a gathering of fairly notable scientists. And so the great dean of Berkeley said he'd be glad to. And so he brought together people from all walks of life and scientists and physicians and people, and some of them, actually were opposed to fluoride. And the president of the local dental society called him up and just read him the riot act. How dare you have these people, like anti-fluoridationists, in this meeting? This is for the children. This is to help the children stop tooth decay. We don't need these people with these crazy ideas about fluoride and stuff like that. After he got through ranting and raving, the dean said, well, I think you misunderstand the role of education, Doctor. At Berkeley, what we try to do is to bring together people from all walks of life, people who have knowledge, skill, education, abilities, and ideas. And then we present them to the students who are to listen to these ideas. And then with the training that we give them here at Berkeley, they can separate information that's valid from information that's invalid. And he said that is our role as a higher education facility. And that I can't imagine that we'd make a decision of such importance as the health of children without having all the information available. Well, the dentist said, that's not the way we did it in dental school. We had to memorize everything. No thinking aloud. Well, the Academy has invited Jim Moore. Lure. We have a call for Jim Lure, emergency call. He's wanted outside in the hallway. We have a call for you, Jim. So what we've brought today here are people with divergent opinions. You won't find these people telling you what you memorized in medical school or dental school. You won't find these people telling you what is already known as to be true by everybody except these speakers. And what they're going to bring to you are ideas that may be new and different. They bring to you ideas that you haven't dealt with before. It may be uncomfortable. It may be exciting. It may be innovative. And it may just be the kind of information that you come to the Academy to seek out. And that's what today is going to be about. And so fasten your seatbelts, and I'm going to have our incoming president, Dr. Richard Fisher, thank you, God, introduce our speaker and tell you what's going to happen today.
Thank you. As Dave said, for those of you who've been regular members and attendees at our recent seminars in the past couple of years, many of you have seen some of the things, or at least pieces of some of the things that will be presented today in a little larger entirety. And I'm very excited at the speakers that we have today. I think this is probably the finest 2 days that we've ever put on in the quality of speakers, and I think Dave really, and his staff, and Betty really deserve a wonderful round of applause for the work they did putting this together. I think if there's a theme for today, it's probably paradigm shifts. I think we've got about 3 major shifts being presented today. Those of you who've heard in the past couple of years Dr. Dave Ganong speak and Jess Clifford speak on bits of the Somatidian theory I thought it was time that we get the larger picture and to see how this fits in and to bring this information and how dentistry may impact on this information. The speakers that we have this morning are from eastern Quebec, Gaston Naesens and Dr. Jacinte Lavesque. Now, those of you who aren't familiar with Naessens' work, I'd like to just read to you a brief excerpt from an article that came out of Bioscience and Technical News last year. It's very difficult to introduce this man because he's done so much, but I'll read this brief paragraph. It says, the medical and scientific discoveries described earlier in this report distinguish Gaston Naesens as one of the greatest scientific minds of this century, perhaps even deserving of the next Nobel Prize in medicine. But his incredible genius does not stop there. Naesens has not been content to merely invent one of the world's best microscopes, redefine human biology, discover the hidden causes of degenerative disease, and develop a reliable method of pre-diagnosing specific degenerative diseases before their actual onset. Not at all. Instead, he has gone on to single-handedly develop, test, and prove the effectiveness of a unique new medical compound that restabilizes the immune system in victims of degenerative disease, allowing the body to completely heal itself in many cases. I'm not one to, those of you who know me, I'm not one to overstate things, but I don't think any of this is an overstatement at all when we describe our next speaker. I think there are a number of people I know in this room today who will attribute the love, the health and lives of some of their closest loved ones to the work that this man has done. And it's an honor to have him here today. He's going to be assisted by Dr. Lavesque, a close collaborator and friend, and Dr. Lavesque in her own right is a director of a clinic in Quebec and a practitioner of Oriental medicine. And I can tell you that aside from the credentials that they bring, that on a personal level, Mr. Naesens is not only all that it says here, but he's a charming, warm gentleman and a compassionate humanitarian. I'd like to welcome Gaston Naesens and Jacinte Lavesque.
Chers membres de l'Académie internationale de médecine orale et de toxicologie, juste un moment. Éminents invités, organisateurs de ce symposium, mesdames, messieurs. Je suis très honoré d'être inscrit parmi les conférenciers de cette 10e réunion annuelle. Je souhaite que les quelques instants que nous allons passer ensemble vous renseignent davantage sur la théorie somatidienne et sur ses applications possibles dans votre spécialité. Comme je ne parle pas anglais, Madame Jacinte Lavesque a bien voulu être mon interprète et a accepté de vous présenter cette conférence. Merci de votre compréhension. Jacinte.
Thank you. On behalf of Mr. Naesens, I will translate the last few words he's just said to you in French. Dear members of the International Academy of Oral Medicine and Toxicology, distinguished guests, to all the organizing team of this symposium, ladies and gentlemen, I'm more than honored to be invited at this 10th annual scientific symposium of the IAOMT. I sure hope that the next moments that we're going to pass together will inform you briefly on my research work, and more important, will lead to explanations and direct applications in your dental field, either in therapeutic or in research. Since I don't speak French, I rely on Mrs. Lavesque to translate the conference. So, dear attendees, I think it's a challenge to present to you the theory of Mr. Naesens in such a short period of time. But we've gathered up the general information, and I'm sure questions are going to be coming up in your mind. And we know that this is something normal, so just don't worry about it. We have planned to work this way. The first hour, I will talk directly to you to explain the basic principles of how we got the evolution, I would say, of his research work that has led to the Somatidian Orthobiology. And in the second part, we will work with video pictures of live blood tests done on his somatoscope, and Mr. Naesens will do comments that I will translate to you. And the third part of the conference will be reserved for questions or any type of more questions that you have that we'll answer. So I think it's very important to distinguish different things. Mr. Naesens has a very special, I would say, origin. He was born in France, as everyone knows, and this you can follow on the appendix number 1 of the sheets that we have given to you. He was born in a typical French family. He was the 4th child of a family of 4, and there was 10 years difference between himself and his older brother. So he was brought up as if he was a lonely child. So I think it's important to mention because he's a very solitary person. He likes to do his things very quietly, and he's, I would say, a very low-profile person. In his life, there were few things that has probably influenced his way of thinking and his personality, is that he lost his father at an early age. He was 11. And after that, the Second World War declared in France. So this did change a lot of things in his life and events, and he had to adjust to a lot of circumstances. If I start with this information, I think it's important because Mr. Naesens has, I would say, personal abilities to build up things. And since he was brought up during the World War period, this was something that was, I would say, validated a lot of times because he was like a little bit responsible for his mother, and very early as a teenager he used to work and create things, and he had developed a very creative way of behaving. When he needs a tool, he doesn't go and buy it. In his mind, he builds up the tool. And again, today, he's still like that. When he needs a tool repairing anything, if he needs something, he's going to go and build it in his workshop. So I think you have to understand that it's a mixture of different personal abilities that has led Mr. Naesens to the, I would say, the building up of his somatoscope. So in order to maybe change a little bit the discussion, we will go on with different slides that I'm going to comment. And as I say, if there's any question that comes up, just write down your question, and we'll see that it's all answered before the end of the conference. So we're going to go on 4 different slides. You will see pictures that were not yet published. I looked in his old trunk and I found out pictures that might be just fun to see. Okay, so this is Mr. Naesens at an early age, and you will see in the preceding pictures that very soon he was highly attracted to anything that had either wheels or that was mechanic or that had movements, he was highly attracted. So I think you have all read the book of Mr. Bird, and you see again he's with something that has wheels and runs around, and as a young child he took like the apparatus of an alarm clock and plugged it in his little car and had this little car run around, and he was always looking for something mechanic. Again, when I said to him that we would show pictures, he was not too willing to do it. He said, they're going to find out that once upon a time I had some hair. I have to say that in the French culture, as children, we always wear, same as in Quebec, even in France, those little pockets, cotton pockets with a little block of camphor. And I'll explain to you how the idea of camphor came along for his product. Okay, this is Gaston Naesens at 18 years old. He had built himself a car of his own creation. He also had built himself a scooter that he used during war, and that scooter worked with wood. He would put wood into his scooter, and he would go around. And also an airplane that he did put, but his mother burnt it before he had the chance to try it. She didn't believe that it would go up, but when she realized that it would go up, she burnt it. So now you're going to see a few steps of Mr. Naesens' career. The whole story of Naesens started in 1963, public story, because he was working before as a scientist. But in 1963, that was when the first trouble started with the French Medical Corporation. So here you're going to see different cutting of papers that shows that a lot of paper was written on Naesens. Here, the picture is not very well clear, but you see that when he was in Corsica, they needed a troop of 350 private police to keep the peace on the island, because everybody was trying to get in the island to get the product, Mr. Naesens, which was GN Anablas at that time. So here you see a picture of Professor Denois, who was one of the major, I would say, expert on cancerology in France at that time, and they had promised Naesens to work on a 2-year basis to evaluate his product, but 4 days after, without no further evaluation, they decided that the product was not good, and that's where the trouble started. Okay, so we maybe bring up the light. So this is just a first, I would say, overall review of his career. We're going to pull l'arrêté. So as a scientist, as a young biologist, he was always worried about something that he would see very often in the blood, and what we commonly call artifact. And once he was always questioning, asking questions to his teachers, but his hematology teachers always answered that these were artifacts and not to worry about it. But he felt that it came out too often to be something that would be artifact, and that's what started the whole process. So he decided to work on a way to, I would say, upgrade optic microscope of the time. And since all the optical companies were working on the numeric optic apparatus, he decided to work on the light source rather than to work on the optic. So he's going to explain how he got and what's the basic, I would say, functioning of the tool that he finally got well organized, that he has called a somatoscope. On peut y aller.
Microscopic observation we have perfected in the course of our 43 years of research. The primary quality of this apparatus is that it permits the observation of living elements and allows us to follow their polymorphism at magnifications reaching 30,000 times with a resolution in the order of 150 angstroms. The underlying principle of this apparatus is that the frequency of the observing light can be greatly increased. Two light sources, one incandescent with a wavelength of 3,300 angstroms and the other ultraviolet and set at 1,850 angstroms, are mixed together to produce a third beat wavelength. This resulting wavelength is treated by a monochromatic filter to produce a ray. The ray is subjected to a magnetic field and split into parallel rays, the Zeeman effect. One of these parallel rays is run through a Kerr cell to boost its frequency. This light ray, invisible to the naked eye, analyzes the sample to be studied.
Okay.
So we'll have the chance to speak later on about the condenser. This is the somatoscope, because at that time, let's say between 1949 and 1954, he worked at it all the time, trying to ameliorate the situation. And finally, in 1954, he finally saw what he always had suspected was these tiny little particles moving around that he has called the somatids. Okay? For one thing, he was highly criticized because of the fact that he was the only one to have this tool. But in 1988, he worked on a condenser that now can be adapted on any brand of optic microscope. So we'll explain later on
Gaston Naesens, what is a somatid?
If we could bring down the light,
A
because there's maybe 12
somatid is a
minutes.
basic living particle. It is indispensable to life. We find it in both the animal and the vegetable kingdoms.
Sans elle, il n'y a pas
Without it, cellular division can't take place.
polymorphisme.
It is polymorphic.
Nous avons pu la mettre en culture.
We were able to grow it in a culture, and that's where we observed its polymorphism in two cycles.
D'abord un microcycle.
First, there's a microcycle, during which the reproductive hormone that permits cellular division is developed.
Ce cycle est stoppé.
This cycle is stopped by inhibitors in the blood and during certain illnesses, including degenerative diseases.
Ce cycle
This cycle, this microcycle in 3 stages, keeps going and becomes a 16-phase cycle.
nous allons
We're going to demonstrate all this for you in just a little while. But to answer your question, the somatid is an indispensable element to life.
How far back do your observations go?
dès 1940.
In 1949, when I was working in hematology, I had the feeling that I wasn't seeing everything there was to see in blood.
Je voyais que
I saw something moving, but I didn't know what it was.
avec les moyens optiques
The optic methods available to me fell short of what I needed. I tried to do better, to delve deeper into what I could see.
je me suis penché.
First of all, I concentrated on the question of optics.
Je suis allé en
I
Allemagne.
went to Germany and worked with German artisans who helped me tremendously.
Et ensuite,
And then a quandary arose.
nous avions
We could work either on the lens aperture or on the wavelength of light. All the large optics companies of the world were working on the numerical aperture. So I didn't have much of a choice.
rien fait. Je me suis donc
I concentrated on the problem of light wavelengths. That's how I perfected a system that gave very worthwhile results and which enabled me to develop a microscope that allows us to see this famous particle. Little by little, I was able to observe it and I extracted it from the blood. I was able to isolate it and grow it in a culture, and that's how I established its polymorphism.
What?
Okay, so before we go on, when he explains that he isolated the somatids, it's quite easy to say, but this process took him a lot of time because there was no way to do it that was already done. He was really a pioneer in that process, and this is something that he took a lot of years to put and do and to finally be able to have pure somatids. It's just until then that he was able to see in culture what would be the complete polymorphic cycle of the somatid in
Using the
culture.
somatoscope, we have been able to observe within the blood an elementary particle endowed with an electronegative movement of repulsion. We have called this particle the somatid. The particle is minuscule to the extreme, varying in dimension from a few angstroms to about 1,000. Still, with the somatoscope, we have been able to observe its polymorphism clearly. The surprise for us came with the discovery that in this cycle we found figured elements usually observed in the blood samples of healthy individuals, but also seen in blood samples taken from individuals suffering from a variety of diseases. For comparison's sake, we have set up two microscopic examinations side by side. On the left is a blood sample observed using conventional methods. On the right, a fresh blood sample seen through the somatoscope. Here, we would like to present the following correlations. In the blood of healthy individuals, we have observed a microcycle composed of somatids, spores, and double spores. In the healthy organism, the evolution of this cycle, starting from the somatid, is brought to a halt at the double spore stage by blood inhibitors. These can be either mineral substances, such as brass, mercury, or lead, or organic substances, such as cyanhydric acid, diastatic poisons, etc. In the course of this microcycle, a growth hormone is formed that is indispensable to cellular division. This phenomenon has been observed repeatedly in vitro cultures. If, under the effects of stress, or for that matter, any biological perturbation, the blood's inhibitors are diminished to any considerable degree, the somatid's microcycle evolves into a cycle that is both different and polymorphic. We then see the appearance of the various stages of a macrocycle, 13 additional phases in all. First, we notice a bacterial form that is the normal evolution of the microcycle when the inhibitors have been diminished. This endogenous bacterial form has been observed by many researchers, Germany's von Bremer being one of the first. The double bacteria which evolves from the preceding bacterial form is often observed in blood smears. Its particularity is the ability to divide itself by scissiparity to form rods. The rod form looks like a bacterial form, except that it is longer and its cytoplasm seems empty. It should be noted that this bacterial form possesses two terminal spores. The granulated double spore bacterial form has a cytoplasm filled with granulations that begin to move. The maturation of the granulated double spore bacterial form results in a mycobacteria well known to microbiologists. The cytoplasm is also self-developing. The mycobacteria that we have just seen has developed further and formed bubble-like enclaves to which it owes its name, bubble mycobacteria. Here we see the bursting of the bubble mycobacteria and the release of the elements of its cytoplasm into the medium. The yeast-like formations that result from the bursting of the bubble mycobacteria have a diameter of 4 to 5 microns. Even at this stage, they give evidence of a centrosome. The yeast-like formations proliferate and become ascospore forms, precursors of mycelial elements. From an assay form, we can observe the formation of a thallus, in which the cytoplasm gradually takes shape to constitute the young mycelial form. It is through a conjuncture and with peristaltic movements that the young mycelial form develops a thallic cytoplasm and eventually becomes an adult mycelial form. When this mycelial element reaches full maturity, its cytoplasm is extremely active. And when it bursts, it releases an enormous quantity of new particles into the medium, each particle capable of duplicating the entire cycle. Emptied of its cytoplasm, the thallus has a fibrous appearance. Incidentally, it is this residue from the Somatidian cycle that is often observed in blood smears and dismissed as an artifact of coloration. It must be underlined that these forms of mycelial characteristics do not answer to any of the criteria of fungal growth. In fact, they are not affected by massive doses of amphotericin B, fungicide, or any other antifungal substance. The preceding observations lead us to a series of postulations. 1. The somatid is endowed with polymorphism, a polymorphism controlled by blood inhibitors. 2. Growth hormones are generated during the somatidian cycle. 3. In both the animal and plant kingdoms, cellular division requires the presence of the somatid. 4. When blood inhibitors are lacking, growth hormones are allowed to increase until they threaten cellular metabolism. Degenerative diseases are a consequence of this disorder.
Okay, so we have seen the complete cycle of the somatide. The most important thing to understand is the somatide is a witness. It's not the cause. It's a witness of the chemistry of the blood that's regulated by the blood inhibitors. Blood inhibitors are not, I would say we have a lot of research to do because all the game of the cycle is played between the phase 3 and the phase 4 of the cycle. There's so much to be done on that specific part because we feel that the key to the disease is research done on these blood inhibitors. It's really the key that permits the cycle to stay either in what we call microcycle, or either a macrocycle, which is a witness of either health or a witness of weakened natural defenses. It's important for you to understand that while Mr. Naesens was in France, in Paris, during, let's say, the first years of his career, when everything was quiet and he was not yet a public person, he used to have 2 labs and work in direct collaboration with doctors in Paris. And these doctors would send in by taxi blood smears with different numbers, and that's where he could make correlation of different disease and what he could see in the blood. That's how he got to see that cancerous, let's say, a diagnosis of cancer would have a certain picture, or multiple sclerosis, or coronary disease, or whatever. So this is how he started to make correlation. And in 1964, when his both labs were confiscated and all the material also, he had more than 10,000 files. So that's how he got to tell us the picture, because when you look at it, it's easy now to see, and you say, well, okay, this goes with, but that's how he previously did the correlation. And I think it's important for you to know this information. So as we have seen, when you look at this directly, usually scientific people always comes up with 2 arguments, that they're not convinced that this particle moving around is a somatide first, and they explain it more with the Brownian movement. So the next little piece of video will explain to you that it's going to show you the difference between the somatide, the chylomicron, and the lipoproteins. We can go on further.
At this point in my exposition, you might well be saying, nothing you have shown us so far proves that the motile particles observed in blood plasma are really somatids. I wholeheartedly agree. We will now move on to an experiment that begins with the placing of a blood smear under the somatoscope. We can see the figured elements of the blood, and among them, bright and motile particles. Could these be chylomicrons or lipoproteins? To find out, we can raise the temperature of the somatoscope's heating stage. It is usually set at 37 degrees Celsius. First, we will increase the temperature to 54 degrees Celsius, then to 70 degrees Celsius. Immediately, some of the bright points disappear, while others become immobile. However, some of the bright and motile particles continue to spin about. What do you think they are? Let's repeat the experiment, but this time with VLDL lipoproteins. Their dimension is known, from 2,000 to 3,000 angstroms. The same phenomenon is observed, and the remaining motile particles continue their movement.
Refaisons maintenant la même expérience.
Now we apply the same procedure to HDLs. We know that their dimension is from 300 to 500 angstroms. Usually, HDLs cannot be detected with optical microscopes. Under the somatoscope, they are perfectly observable. As we reach 48 degrees Celsius, the same phenomenon is produced, and the motile particles are just as agitated. Even at 70 degrees Celsius. We can make 2 conclusions from this series of experiments. 1, the somatoscope allows us to observe HDLs, and therefore particles of 300 to 500 angstroms. The particles that remain motile even after having been heated to 70 degrees Celsius cannot possibly be chylomicrons or lipoproteins. Therefore, they are in reality somatids. since somatids are not at all sensitive to heat.
Okay, so I think it's important for us all to well understand that the basic quality of the somatoscope is not necessarily its magnification power, but its high resolution. Because people always, well, this tool is seen as something unique, and it is unique, but it's important to understand that it's the capacity of seeing small details in the picture that gives us a lot of, I would say, capability to do work with it. The next slide that you're going to see is something very special. It was captured. Mr. Naesens was not necessarily looking for it, but it was captured on a time code. He had put the blood smear of a patient that had prostatic cancer that was never treated either with chemo or he was always treated with natural procedures, so we knew that this blood was like pure. He did put this blood smear on a time lapse, and he let it go for a few hours, and after 6 hours he got back into this lab and looked at it, and I can still remember yelling. He was yelling as if he had found something very important. So we're going to show you the little piece of slide that he captured showing us the polymorphic transformation that was done directly in front of our eyes, because we often see it from one phase to the other, but it's not always easy to catch it on the spot. Okay, so this little piece of video is going to show you the transformation of a bacterial form. We're going to see the bacterial form that's going to switch to a liverate form, yeast form. So we can go on. It's about 2-3 minutes. Ça va avancer. So you just watched this bacterial form right here. This.
Right here.
Yes.
Transformation.
Okay, and just look at it again. It's gonna still. So this is on a time lapse, okay? But he thinks that the changes occurs probably in a matter of seconds, between 8 to 12 seconds. So again, this liverate form divided in 3.
Et chacune de ces formes a reformé un cycle complet.
And he said that each part, okay, later on separated, went into the plasma and started like a new cycle, continued the cycle, as if they had the power to go on again. Est-ce que c'est possible de le reculer juste pour le voir faire encore? Ou ça peut aller? Are you satisfied with this, or would you like to see it again, this switch?
C'est difficile de le reculer.
C'est difficile?
C'est pas assez clair. OK. Donc, j'ai pas de lumière pour le retourner.
He said it's a little bit difficult to switch it, but just, I think you have well seen the transformation that occurs. So it's certainly a live proof of the polymorphic action of the somatide. OK? Fait qu'on peut continuer encore.
Vas-y. On peut y aller?
Oui, vas-y. We can go on.
What do you mean by Somatid orthobiology?
The very etymology of the word orthobiology indicates that it's a kind of biology that is adapted and tailored to the Somatid theory. It's impossible to understand orthobiology if you don't understand the Somatid theory. But to understand the somatide theory, you have to have the proper means of observation, and you especially have to understand the basic principle of the somatoscope.
Just bring the light up because we're going to need the light for a few seconds. 2 minutes, I should say. Thank you. So if we make a small conclusion on that section, we can say that the somatide, to Mr. Naessens' opinion, is probably the smallest unit of life. And to his opinion, is certainly a precursor of the DNA, because the somatide is a carrier of the genetic material. Okay, this is his hypothesis. He doesn't know yet how it works exactly. He's doing active research on it, but to his opinion, the somatide is like a condenser that permits certainly a link between energy, any type of energy, that is transformed to be materialized in something that we call life. So the somatide is something that is a link. So this is the reason why it explains that the somatide, when the surrounding is not good in condition, can stay in a latent form, a resistant form, for long period, for years and years and years. And when the surrounding comes up that is capable of supporting life in different forms, either human life or either vegetable type of life, then some type of life appears. So this is highly important for him. Also, he has found somatides in, let's say, lime or stones or even in mineral kingdom. He can still see somatides acting. There's a difference, I think, important that it has to be clear. The somatide in the body, if you see it in the body, is not indestructible. Okay? It can be eliminated because the quantity of somatide can vary. It can change in the body according to the chemistry and the biochemistry and all the blood inhibitors. When we say that the somatide is resistant, it's when you take pure somatide, extract somatide from the blood, and you make a culture out of it, and you bring it to its resistant form. It is a solid, very solid, reddish color, and it's really very hard. And that state, it's indestructible. You can put radiation on it, you can put high temperature, it cannot even be cut. It's very hard to cut it. It always bends how do you call that? Comment est-ce qu'on appelle ça, celui qui coupe le somatoscope en anglais? Les tranches de
Microtome.
A microtome, I don't know if that's the right word in English, but it always breaks the quartz, the blade. Okay, so it's important to understand that when we say that it's indestructible, it's in pure form. It's not in the body, because in the body, somatides level change according to the chemistry and according to the nature and presence of different blood inhibitors. Okay, but when the surrounding is not very strong, or for whatever reason, it stays a somatide, but in a resistant form. It just encapsulates and stays and waits until something happens. This is important to understand later on in the... So I hope that... Are you catching up? Is it too fast, or is it clear? Or at this point, I feel to ask, is there any questions that you'd like before we go further on? Okay. You mean the somatide? Well, in the blood, it's vulnerable to blood inhibitors. It's the chemistry of the blood that will change, I would say, the behavior of the somatide. If everything is fine, if the chemistry of the blood is in what we call normal in a sense that the natural defenses are strong and the person is what we call healthy, you will see the three first phase of the cycle. And No, they will continue to grow. Because you have to understand that the first somatids that appear in the body are from the gametes, the reproduction, the ovum and the sperm. These two cells are carrier of the first original, I would say, type of somatids that a person will have. And from there, the cellular division is activated and the different, I would say, specialization of organ are being done, embryology, and then the body, behaves normally with different specific function. And to Mr. Naessens' opinion, he thinks, okay, that the white blood cells, platelets, and red blood cells, and finally different organs in the body are secreting or producing different types of somatids. But when we look at a blood smear, we have it's like a package of different types of somatids because the blood goes everywhere. It's in circulation, different types. He has not yet been able to recognize either the chemistry or the nature of different types of somatids, but we can very well see on the somatoscope that the red blood cells is a major production is responsible for the production of somatids. We can see it being done it's like a liquid form that is expulsed outside in the plasma, and once it is in the plasma, it gets this more material form with this electro movement that we have just seen. And we know that the somatid has a nucleus and a negative shield around. This has been seen and well seen on I would say, an electronic microscope also, like a cut of the somatid. Okay, I see a question there. If you don't mind, I'm just going to go on with questions if there's not too much so that I would say the understanding keeps up progressing, okay? Known? This is what he called blood inhibitors, okay? As an example of somatids, when you take a pure culture of somatids and you inject mercury, okay, because you're concerned with mercury.
En solution physiologique.
In physiological solution, okay, so that it changes, and you see the evolution of the somatid going through a macro cycle. It activates this process, or depending on the quantity, depending on the concentration, it can bring back the somatid into a resistant form. So, as we said previously, we know that there's something major to be looked at what we call blood inhibitors, but there's research to be done there for the next 200 years. We don't have all the answers for that.
Okay.
Okay, I think Dr. Fisher here has a question.
Follow up on that. So I understand that, let's say mercury or some other toxin, depending on the concentration, can either stimulate it entering macrocycle or keep it in microcycle, depending on
Or bring it into a resistant form, like stopping all the evolution of the cycle and bringing it into a resistant form. It's three possibilities. Okay?
Okay, bon. Continue.
Je pense qu'il faut faire le... Parlez juste, I'm just going to see what's next. I think it's on the 740 next. Just go. OK, on arrête. Non, c'est pas ça, tu peux le faire reculer.
Okay.
We're going to bring the light up again.
Okay.
Okay, so I think there's another question. Yes? In cultures and also in blood. Pardon me? Okay, but we're going to put it really clear in culture, and then in blood we'll see different patterns occurring. Because when you look into the blood, you have like two different things that are being one on top of the other. You have the cycle of the somatid, but you won't see all the phases in the blood. You will see different phases in the blood, depending on the chemistry. And you will see different things happen to the figured elements of the blood. Because since the red blood cells are producing the somatids, you will see different, and that's what we'll do in the second part. We'll try to explain to you how we look at the blood and how can we have different answers of what's happening in the body just by looking at the blood. I see hands there.
First of all, do you have any idea how long it takes to go through the cycle? Number two, do you know what the times are for the various steps of the cycle?
In culture, okay, if you start with somatids, you can see the complete macrocycles in 90 hours. In culture, that means with ideal condition of temperature and in really a good surrounding for the somatids. In the blood, there is not yet. We cannot say yet. Okay, all that we can say that Mr. Naesens has observed is that if you see the complete macrocycle, let's say to the phase 16, let's say the chalice form, you can see this in the blood 2 years previously before you're going to see clinical symptoms that can be seen or identified with classical, normal, orthodox test. So it means that for a period of 2 years, the natural defenses of the body are trying to push back this macrocycle into the little one. The natural defenses are, and also this is the maximum time, but depending on I would say the strength of the person's defense, it might be done in 6 months, it might be done in 3 months. That's probably what decides the evolution of disease in one person. That can vary from one to another. Okay? Yes?
The difference in observation between Enderling's work and Dr. Knopf's?
To tell you the truth, I'm not familiar with underlying theory, okay? People that are familiar with the theory certainly see signs. I'm sure that these two men are seeing the same reality and are looking at it through a polymorphic view. But at this point, I don't even know exactly the theory of underlying, so I wouldn't be comfortable to do it as a point of comparison. But if you have the formation, I'm sure that you see different links. Okay? I also have to mention that Mr. Naesens, who was French, brought up in France, did not know about Deschamps until 1982. He did all his work, all his theory, without knowing this man, and Christopher Bird, who was the author of his book, was the first one to speak to Mr. Naesens about Antoine Deschamps. So again, it's to see that these people had been working on similar things, and I'm sure there's a link somewhere between what they have seen. Certainly, it can be all that different. We're looking at life, certainly. There's a question there?
What do traditional microbiologists and orthodox medicine say about these observations?
Okay, traditional biologists first, they're very, I would say, upset, and I would say that they don't even look through the microscope, because if they look and they see, they will have to believe, because it's so easy. So their attitude is, the first thing that they mostly do is to criticize the somatoscope. And since Mr. Naesens is not, I would say, an engineer in physics, they rather say that it's quackery. It's easier to say that it's quackery than look into it. And I've seen many scientists to come in the lab, and they rather not look at it than to see something that they won't be able to explain. They come very much upset. I've seen various patterns of people highly upset, and let me tell you. So, as we say, it's easy, it's very simple, it is not complicated to see, and you will see later on the difference between normal optic microscopy, what you see on a blood smear, and the same slide, what happens when you look at it with a condenser. The different picture is so obvious that you cannot, once you have seen it, you cannot deny it very long, so they rather not look into that's the general attitude. Does this answer your question?
Okay.
A few of them, okay, are interested, and once they get interested, they always hit the same problem, is that if they go back into their orthodox surroundings, they're going to be considered, or they're going to feel like ridiculed people. They're going to be You know, they're going to say, don't tell me that you looked at Naessens cartoons, because in the scientific, they call it Naessens cartoons.
OK.
Okay? So, we just don't worry about it too much.
OK, ça me voit?
Ça va. On peut... Non, c'est pas ça du tout. Non, on y va avec les... J'ai tout un... sur le C114 à parler, les produits.
OK.
On a un bon 10 minutes. Okay? So, I know that by your profession, you're probably more concerned with the theory than the product. But I feel that it's worthwhile that you understand how his product works, because you've probably heard many things, and I think it's important that you understand the basic principle of his different products. First, I have to say that Mr. Naesens, as he always say, the fact that he has put products into the market is an accident, because he never wanted to put any product on the market. But by the knowledge he got by the view of his somatide and his cycle, he felt that he could do something. So that's how he got to, I would say, he invented the product. It's something that, according to his knowledge of the cycle. So his first GN24, okay, product, he invented the product. It's something that, according to his knowledge of the cycle. So his first GN24, okay, product was one that he put into market when he saw that the cancerous cell was doing a certain fermentation. This is one of the first things that he observed with his somatoscope in the 1950s. So he, seeing that there was a lot of fermentation around the cancer cell, this product was like to stop the process of fermentation. Once he seen the whole cycle of the somatide, his anablast product was what we call a serotherapy. He took the blood of a sick person, did extraction of the somatide, put this somatide into, I would say, a healthy horse, got the serum of the healthy horse, and then injected back into the patient. This was a serotherapy. 714X works altogether differently. 714X is a compound that has basically, it works on the principle that the anarchic cells, for whatever degenerative disease in the body, has a high quantity or a high need of nitrogen. This is the principal hypothesis. He's not the only one to work with this. This was, there's a lot of writings and publication on this, and it is known under the theme of nitrogen trap. It is well documented, and there's a lot of research in the 1950s that looked at cancer with this angle. It was lost a little bit in the 1960s. We went to something else. But in the 1940s and 50s, which was the first years of his career, there was a lot of, I would say, research done on the host between the person and let's say, the cancer. That the cancer could not live by itself. It was hosted by a person, and there were, like, I would say, some kind of a link between the person and the cancer. So we did a little schematic picture. We know that it's not very scientific, but we felt that it's important for you to well understand that the 714X is not a cytotoxic product, which means that if you inject 714X into a tumorous mass, you're not going to have much results. It's not done, it wasn't invented to work this way. So here again I have to explain that as a child, Mr. Naesens, with his little block of camphor that his mother used to put on him, one day, just for fun, did put a little chip of camphor in a tube of water. And he saw this little piece of camphor disappear, what we call sublimation. He did it once and twice, and he found it was really funny. So he took his little block and put little chips of camphor and tied it to a little boat that he put into water, and this little boat was running around. So he found it very funny. He played with that for a little while, but it stayed in his mind. He never thought of it until later on he realized that if he wanted to help the cancer cells, because this was his major, I would say, concern, he had to bring nitrogen to these cells. So he was looking for a carrier, taxi, that would bring the nitrogen to these, I would say, anarchic cells. So there was the idea of taking camphor. So the active ingredients in 714X are the camphor molecules, to which there's nitrogen that's linked, and to which there's organic salts. So the camphor does not necessarily have a therapeutic effect, but he knows and he has observed that camphor, if you put it into the body, will have an attraction, a high attraction that we call trophism for the, I would say, unhealthy cells. So he used this as a taxi. The nitrogen is brought along to the cell, which permits them to be fed in large proportion, and it makes them very happy for a little while. You have to understand that what he has called the poisonous substance, we often call co-carcinogenic K factor, which was not invented by Mr. Naessens, but by a French eminent cancerologist, also has observed that when you have certain amount of cancerous cells in the body, or anarchic cells, we say cancers, but not only cancerous, when they reach a critical mass, when they're all together, organized, and for whatever reason, if the natural defenses are not behaving correctly, you will see that they will secrete a poison substance that will block the effect of the what we call immune system and also the natural defenses. This blocking is done purposely to go and steal the nitrogen because they're greedy for it and they need high quantity of it. So the 714X, when it arrives into the circulation, brings high quantity of nitrogen, so it's like a little party for the cancer cell for a little while. They forget to secrete this poison substance. They don't need to do it because they're well fed with nitrogen on a long period. It's something that it's done in little quantities, but every day. So they're not much worried. It comes along very progressively and continuously. And this is why the treatment has to be done very strictly, not to miss a day, because it breaks the cycle of the arrival of nitrogen to the cancer cell. So after a while, you see less and less and less poisonous substance in the blood, which he is not able to identify yet and to see. We know it's there by the effect, but it's not yet, the chemistry of that substance is not yet identified. He's working very hard on it, but it's not yet clear. And then finally, I would say the anarchic cells being well fed up, it just permits the natural defenses to start to pick up again and come and surround this region of unhealthy cells and eliminate them as they would for any foreign body. Okay? So there's a difference for us between immune system and natural defenses. Okay? Because sometimes you're going to hear me say immune system. By definition, the immune system is something that reacts to outside, strange body from the outside. But in this case, it's not coming from the outside. It's coming from the inside. It's like the polymorphic cycle, and it's done inside the body. It's not necessarily a strange body. It belongs to the chemistry of life inside the body.
When you mention nitrogen, are you talking about an oxidized form or a reduced form of nitrogen?
Quand on parle de l'azote, est-ce que c'est une forme oxydée ou une forme réduite?
Forme oxydée.
Oxidized form, linked. Okay, I don't have here all the chemical components, but this is going to be available in a book that Mr. Naessens is going to publish very shortly. So I felt that for the purpose of your group, it was not necessarily a 714X, but I think it's important to understand the basic way it acts in the body. Okay, so far, is there any questions that you want more answers, or I see a hand up there. Yes? In the 714X, something that I have to say is their organic salts, and the specific action of organic salts and I would say the mode of application of 714X that is injected in the lymph directly helps, I would say, to repair the side effects of chemo or any other type. So what he suggests for patients I would say, on a more clinical base, is that if the patient decides, because it's a matter of choice, freedom of choice is whatever the patient decides. We know that chemo, we know that radiation will have side effects, but for whatever reason, if he decides to go on with this procedure, Mr. Naesens suggests that he would do a round of 714X first, so that the natural defenses are strong, and then if he does chemo, just to go on one chemo treatment, one 714X, and to go on like that, but never to do it in the same time, because they're not working on necessarily the same level. He also has seen that all degenerative diseases have a common point, is that their lymph, circulating lymph is all clogged up in a gelatin form. So the toxins cannot go out of the body. It seems that it's all stuck. And with the 714X, 15 seconds after the first injection, we know that the lymph is being clarified, because the salts in the 714X works on the albumin concentration of the lymph, and we can see it. We can see it physically. When we do seminars, we do it physically to show you what a drop of 714X does on coagulate albumin, but clinically we can see it on patient, because after a few seconds they have like a flush. They're all red, and we can see that there's something, circulation is being activated. Okay, so as we say, we're not, for sure it's a matter of personal decision if a patient goes into chemo or radiation, and we know that this is the major treatment proposed, and sometimes for some reason people cannot go through this procedure, so they go directly to 714X, but we can deal with it. It's always better to go directly to a therapeutic like this without, I would say, all the waste product of different types of intervention, but we live with the situation depending on what the patient decides. Does this answer your questions? Okay. Okay, so I think this is, yes? If what? Yes, the procedure is a specific lymph node in the groin region on the right side of the body. This has a specific purpose because of the I would say, anatomy and physiology of the lymph system. With the injection on the right side, you have a better drainage. You cover a wider, I would say, perimeter of the lymph system. For whatever reason, if it cannot be done on the right side, let's say if the groin, if the lymph nodes have been removed, or if it's impossible, we can do it on the right side, but preferably on the left side, I say, but preferably it's on the right side. Yeah, this is the basic procedure to do the injection. That's what he recommended. He has tried it in different places, and he feels this is the one that's easier to do and has the most effectiveness.
Okay.
Non, on peut pas. Temperature of the body? Est-ce que tu penses que la température du corps peut faire activer le cycle d'une forme bactérienne, une forme de virus? He doesn't think that the cycle is relied to temperature.
No.
What he has observed. Not directly. It might have an indirect effect, but not directly.
Does the patient experience burning or itching or other side effects from these injections? What are the reasons for it?
Once the injection, if it's well done by a person that's well trained to do it with, respecting all the procedure, like the ice before and all the specific procedure of the injection, the patient doesn't feel anything when it's well done. But you have to respect, we ask patient to put ice on the groin region, not because of the needle that hurts, but because camphor in the 714X is highly volatile. And if you don't bring the lymph node region cold, you will have a reaction of evaporation of the camphor. That's what's going to bring the itching. It's not the fact that you go into the lymph system. So if you put ice before, your product is cold, and the regular procedure or technique are well done, the patient should have no discomfort. Okay, so I think this covers up pretty much the overall review of the theory, the somatids, its behavior in the blood, and more, I would say, the theoric part of Mr. Naessens' work. As you have previously heard in his explanation on the video, he said that the somatid can be seen either in the animal or plant kingdom. So for the purpose of the conference, we took different extract of vegetable species, and you will see different types of somatids and their behavior in how they behave. So you will still see this little mobile particle going around with the same movement, but you will see different things. And what's interesting with plants is that you also see pigmentations, different pigmentation, chlorophyll and keratin and different things. So we're just going to have a few minutes to see that, again, anything that's alive, anything that is alive will have somatids, which are necessary for cellular division. This is the juice of green onion. The lights, please, because this might be a little bit. Qu'est-ce qu'elle dit?
Ça, du carotte, celui-là.
Non, celui-là, c'est les échalotes.
Non, ça, c'est carotte.
C'est carotte?
L'échalote, on l'a placée.
Okay. So you see the movement. This is carrot juice.
L'autre, c'est la betterave.
These are beets. So you're going to see different things, fibers and cellulose fibers you're going to see. But there again, what's important to see is that there's movement. Okay? And the quality of the food that you eat is going to bring like healthy somatids also into your system. You can see vegetable. This is a cell. You can see the cell wall in the. If the juice is heated, certain somatids are going to stay, certain won't show. Well, it's all the theory. I'm not going to go into this, but it's all the theory of eating raw food or not. Or there are certainly reasons for certain types of diets. Okay, so here, on peut juste comme s'arrêter juste un.
On peut y aller?
Non, on va juste attendre un petit peu. We're going to run into, let's say, now blood smears, not somatids into culture, but different live blood tests. So first we're going to see what a healthy blood looks like, the picture. Okay, it might, for some it might be familiar to see, for others it might be something. So we're just going to bring on comments of the different things that you're going to see, so you can just have a look at what a normal healthy blood looks like.
On y va?
Oui. This is a polynuclear white blood cell. Okay, so
Micro. Mets-toi un micro.
good idea. Okay, so these round-shaped are your red blood cells,
This
these
is
erythrocytes.
Monocyte with nucleus.
You see the nucleus of the monocyte, and you see the
Cytoplasm.
action in it. Cytoplasm.
And membrane.
So you can see the fine details of the movement. You see the somatids and the double spores in the plasma that are just moving around.
Are all the little extracellular spots over the somatids?
Yes, those little moving things that you see that are all spores and somatide spores and double spores.
Are they potable?
Are they what?
Potable?
Yes, they're moving around
They do it under their own power.
under their own power, independent of anything. Okay, so this is to see the
Polynuclear neutrophil.
polynuclear neutrophil with
You,
the movement.
you put here
Okay. We're gonna.
Let's
We don't have the control of.
too fast.
But he was searching for platelets. We're going to see platelets a little bit there.
What is the basic technique of collecting cells?
The technique? Oh, this is something else. We'll talk about it later, okay? You mean the isolation technique?
Yeah.
Okay.
Exactly.
Okay. The extraction of some. We'll keep on for that question and we'll see to it later. He was showing a double spore. A spore, okay? So you see different, I would say, somatids. You see, they're so fast. This is more spore, probably a double spore. And you have your red blood cells all around. We've passed on platelets, but it was going too fast. But we'll see some more later on better than. Okay, now you're going to see a live blood sample of something, of a patient with prostatic cancer. Okay, so again, you're going to see the red blood cells, which are
This is platelets.
platelets. We're going. Okay, this is platelets. This is the shape of the platelets that we see on the
These platelets.
on somatoscope. Yes, platelets, which are not like round form, like we have learned in school, but they're a little bit shaped differently. We're going to see them very clear. These are platelets again. Okay, now we're going to start to see different things. All these are red blood cells. You see this fibrillation movement in the red blood cell? This indicates a lack of iron because of the shape of the red blood cell that has, it's like a disc, it's a little bit like a lifesaver. When there's a lack of iron, you see this little surface collapse, and this is what we see on the somatoscope, this fibrillation movement. It indicates a lack of iron. We see it very, very often on live blood taken on women more than men, which is normal because of the periods.
The fibrin.
Okay, so this, we're going to see, usually a live blood test, we see fibrin coming up after 15 minutes. It's normal, that fibrin of the blood. But usually when it's in a healthy situation, the fibrin is like well organized, all straight up. But what we have just seen is like bouquet. It's like a cluster of fibrin. I don't know exactly. C'est quoi que tu montres là? He suggests, okay, this is what we call a parasitized red blood cell. Okay, let me explain this. Parasitized doesn't mean that it has outside parasites. It means that the red blood cell responsible for the creation of somatids.
Bacterial form here.
Okay, you see a bacterial form, but I want to finish my explanation of parasitized.
See?
Rather than expulsing the somatide into the plasma, for whatever reason, the red blood cell keeps it inside, and you see the progression of the spore, double spore, being done inside the red blood cell. So this is something that's going to bring in trouble, because while the somatide is growing inside the red blood cell, it cannot carry oxygen. And we know that the blood cell is going to...
Quand ça explose, voilà ce qui reste.
When the red blood cells explodes, when she's full of somatides that are not being expulsed but kept inside, this is what happens. You see these chains coming along, and peux-tu montrer la forme bactérienne en bas? Là? Bon. You see that part could easily be seen later on as a bacterial form into the plasma. It's just as if the microcycle, the whole cycle of the somatide is being done, but the first 3 steps are being done inside the red blood cell.
Ça, c'est une forme lévurite qui a échappé.
This is a levirate form that's running around there. And there you have platelets, and you have, on your right side, these are platelets. But you see these chains, you see it well, how this is a red blood cell full of spore and double spore that has like collapsed, and that's what's left out of it. C'est quoi l'affaire qui est blanche?
Non,
là?
ça c'est une asque, disons, on va y revenir après.
This is an ASCII, which is the phase 13 of the cycle. We will see it later on, yeah, it's an ASCII. So you see that the general overview of the blood is different from... Okay, we're going to see a lot of ASCII here.
One more.
Okay?
Here.
You see that chain again being formed? And all these white spots are ASCII, which is the phase 13 of the cycle. When the ASCII, okay. Ça va vite, hein?
Ça va vite. Je pourrais
These
montrer.
are clusters of fibrine.
Si je pouvais trouver un moyen d'arrêter.
You see, when he looks on the slide, he was looking for a talus, actually, so we're going to settle back on this. There's lots and lots of it.
Tiens, ça, regarde, c'est pour montrer ça, ce sont des bouquets de fibrines.
Those are fibrin, bouquet of fibrins, which indicates if it's correlated with red blood cells that are done in piles, like in rouleaus, it indicates an inflammatory process that's happening somewhere in the body. Clusters of fibrine like that.
Il faudrait avoir le temps d'expliquer.
Veux-tu l'arrêter? OK. On pourrait-tu la fixer là?
Là. Tout ceci explique... Non.
OK.
Faudrait la
Montre.
différence.
OK. Arrête là, à côté d'un celui rouge parasité. OK. On peut montrer la tête de méduse.
Non, il n'y a pas de globule rouge.
If you look onto
Here,
your...
here, voilà.
Okay,
Ça, c'est un globule rouge parasité, tandis que les autres, ce sont des asques.
the one in the center is a parasitized red
Here.
blood cell. Okay, this one. On the side, all around, what you're seeing is the ascospore, but we call it a medusa head because you see that around this ascospore there's like a circle of high motility. There's a lot of movement, as if there's a crown all around. And this is the natural defenses that are fighting to make this ascospore disappear and make sure that it does not go further on the cycle. So when we see that, we know that the natural defenses are still good. The body is reacting a lot. So the ascospore is being like all grudging to be smaller and smaller.
Encore des chaînes, là.
Okay, you see again chains that are being done, which is a parasitized red blood cells that has collapsed and exploded, so that's what's left.
Ici, ce sont des têtes de méduse. Tu vois, ça
You
bouge.
see, what we call a medusa head is an ascospore that the immune system is... Let me... We have to admit that it's, you know, it's something to look at it because it's an ability to... Pardon me? This blood, it was freshly taken.
10 minutes.
10 minutes.
After
The blood test that has to be done within 10 minutes. After that, you're going to see different things, but you cannot pronounce yourself on anything. It has to be done in the first 10 minutes, the evaluation of the biological. Okay, on peut-tu l'arrêter là? One thing important to say also is that the presence of these ascospore has a diameter that's very close to the diameter of the red blood cells. So if a patient comes along and gets a red blood count, more often than nothing, it is counted. The ascospore looks very much like a red blood cell, and it is counted as a red blood cell. So your patient that has different symptoms like fatigue and feels weak or something goes on and gets a regular, normal red blood cell count because it is done by machines and it cannot recognize since they have the same diameters. One thing also, a parasitized red blood cell is counted as a normal red blood cell, but we know that this one does not carry oxygen. So it brings again the body in a situation where there's a lack of oxygen. So again, it explains fatigue and, you know, different types of symptoms that might occur at the beginning of a disease, indicating that the macrocycle is just about to happen in the body. You see this like funny shape? That's a red blood cell that's going to expulse its different somatids that have been growing inside. So these are all ASCIIs that you see. They're not normal elements of the blood. This is a red blood cell, parasitized red blood cell. So this patient had clinical problem. He was very, very tired, and okay, you see like fibrin being in clusters, not being regular. It just happens like that. Usually we put like a number of 5. 5 is like the top quantity of somatids. This one would have a rating of probably 2 to 3. We'll see in different blood samples as we go further, but for a patient with that disease, it's certainly good to have this quantity of somatids. It tells us that the natural defenses are still in relative good situation. Also, we see this movement around the ascospore. Medusa head, you see the action that occurs around the asci. Because every time the cycle goes on to a next step, it seems that the pressure of the body is put so that it's going to go back. This is a conglomerate, which is, it's like all the waste product of the blood is gathered into one big piece like that. And it usually takes the whole screen. So we call it conglomerate. Usually can contain cholesterol crystals or triglyceride. And it's a little bit like a garbage, garbage bag that's ready to go out. So rather than leaving all the toxins go away, the body puts them in large concentration. So this again is a red blood cell, parasitized red blood cell with an ASCII below. And, pardon me? The lower left, let me see.
Pardon?
This is a red blood cell that has lost its hemoglobin. Instant, c'est une hémolyse spontanée?
Oui,
Spontaneous hemolysis, is that how you say it? It's a red blood cell that has lost its hemoglobin.
This.
Because of the density of different particles, when you put the cover slide, they just, you see, so that's why when you look at a slide, you have to look right in the middle of the slide, never on the sides, because the density makes different particles go on the sides. So that goes with the technique of observing the blood, the live blood. It's certainly a good remark. Quel grossissement ici? C'est à quel grossissement?
Pardon?
Quel grossissement ici?
30 000.
This one is at 30,000. X. He had a prostatic cancer with no chemo done yet, or no, I would say he just learned that he had this disease. So again, you see a red blood cell, a parasitized red blood cell. The what? The rouleau combined with the clustered fibrin usually indicates an inflammatory process. It's not an outsider. It's not an outside parasite. We say parasitized because it is stuck with its own somatids. It doesn't come from the outside. Do you understand that? No. It's not. It's a parasite that comes from within the body. Rather than expulsing it in the plasma for whatever reason, there seems to be an intelligence in the membrane of the red blood cells that keeps the somatid inside. Because she knows that if she liberates it, it's going to go through the whole cycle. So she's just keeping it to make sure that it doesn't go further. It's like a protection process. This one is a talus. Okay? You can see the different threads and its fibrous consistency. So by looking into the blood of this person, we knew that the whole cycle has been done. We could see a lot of ASCII, a lot of the immune system was reacting, but this by seeing this, which is like, let's say, the waste product of the terminal phase, which is phase 16, we knew that the whole cycle has been occurring. We don't necessarily focus, but we see that the Jacinte, I would say, stage is a stage that the body holds on very long. If the disease is preparing, let's say when the body gets into the macrocycle, the bacterial form evolves very fast into the yeast and ascospore form, and that's where the body, there's certainly something that happens there, that pressure is put by the immune system to keep it at the ascospore stage and no further, or to make it reverse. So the body can stay very long at that stage, and that's why we see it very much in the live blood test.
Okay.
Pardon me? No. When we say a bacterial form, when we say a yeast form, when we say a mycelium form, it is because it looks like it, it is shaped like it, but it does not behave like it. The bacterial form does not respond to antibiotics, and the fungic form does not behave to antifungus. Okay? When we say bacterial form in the wording of Mr. Naessens' theory, it's because it looks so much like it, but it does not behave to the normal treatment of bacterial form. Because this is within the body. It doesn't come from the outside. The treatment of 714X usually is done to make this cycle, first it's like a gate. It installs a gate at the stage 4. It brings back the normal activity of blood inhibitors, so it prevents phase 3 going to phase 4, and it permits, it probably stops the whole process of the one that has been passing the gate. So on a short period of time, you are back into a microcycle. And when I say a short period, usually after 21 days, we can look back after the blood smear and it's back into the microcycle. This is all cleaned up. Well, 714X is not working on cancer of prostate. It's a help for the natural defenses of the body to start to pick up. You understand the difference? This again, you see it better, is a parasitized red blood cell.
You see the bacterial form here?
You see the bacterial form? Okay, now we're going to see like different pictures of what we have seen previously is more like cancer, more related to cancer. Now we're going to see something that's typical for AIDS. What do we see on the somatoscope when we work with AIDS patients, HRV or AIDS patients, you will see?
Polynucléaire après 3 heures.
This is a polynuclear after 3 hours of evolution. So you can see that the division of the nucleus is not normal. It does not behave like a normal. You will see the difference with a normal one.
Ce sont des plaquettes qui ballonnisent.
What we often see in AIDS is that the platelets, around the platelets, you will see this ballooning process that surrounds the platelets.
Much mycelium with
This
long trace.
is the evolution into mycelium form. You often see this.
Ça, c'est une
Ça, c'est le syndrome.
cellule de Kaposi avec les noyaux allongés. Et ce qui est remarquable, c'est que ce sont tous des grands filaments qui utilisent.
He said this is a Kaposi cell with all the, the nucleus elongated. What's interesting to see that you're going to see little hair that's going to start to grow on this. Okay, and if you look closely at these little tubules, because they're really tubes, okay, these are white blood cells, des dépolys.
Avec des formes cristallines à l'intérieur.
You see crystalline forms inside the white blood cells, which is typical of AIDS. You don't see this in anything else.
Ça, c'est typique de tous les cas de AIDS.
This is a picture that you see. It's typical of anyone that has.
Les granulocytes forment une ballonisation et ensuite des tubules qui partent de cette partie-là.
All the granulocyte white blood cells usually do like a ballooning, a little bit like the platelets. And from this, I would say, prolonged part, you will see different tubules because they're really like little tubes that are.
Here,
You see that? How
ici,
it evolves?
la formation gazeuse est ici.
You see that some type of a fermentation that comes around, but you're going to see all these little, okay? They're like fine tubes that goes in every direction. And if you follow, you see, you follow it, one of them,
Je puis suivre les virus
he can follow the pathway to virus that are going somewhere else.
et qui vont implanter ici sur autre chose.
So the virus is going to follow this, exactly this, and it's just like a tube to implant a virus in another cell. So that's how the process keeps on. This study has already
Regarde
been,
ici, voilà.
okay, this has already been demonstrated by electronic microscope. This has been taken from a reference, I think it's Scientific American, and it's going to be marked anyway, the reference. Now, this Scientific American of October 1988 has well demonstrated this with electronic microscope. To blood? Well, the somatidian, yes. Usually in healthy person, the kidney does not liberate somatides. Usually you don't find, but if you find somatides into the urine, you know that the kidney is not necessarily in a good condition. It's a little bit like the normal urine test, but this is specific. For the AIDS, you find it in the blood.
Si on revient dans une maladie normale. Si ce n'est plus du AIDS.
Okay, this is not AIDS anymore. It's another picture of, again, another type of...
When you are AIDS,
Okay, so you will have to see that what the picture we see is not, certain things are typical of a disease, but here again, it's another type of cancer. It's not the same one as we've previously seen, and it's always the same, I would say, witness that the natural defenses are being weakened that we see. Medusa head is there, and the chains are present, and you see the parasitized red blood cell at the upper right, sorry. But again here, you see the activity, the big activity around the ascospore to bring it back into, as if it would be neutralized. Here again, there's a high degree of somatides, we could say 3 out of 5. If we see an ASCII that doesn't have this moving action, well, we know that the cycle is going to evolve, and there's like the body is not giving any resistance. It's just going to go and move into the next step. The natural defenses are not at all behaving. The one on the right is a parasitized red blood cell, okay? But they look very much alike because the diameter of a red blood cell and the diameter of a normal ascospore before the immune system grudge on it is the same. So it looks very much the same. We have to be careful.
je pense qu'on est sur des 105 là. Je pense qu'on a changé.
Okay. So this is a different picture of a normal blood also, just to show you that when the red blood cell is clear, you really see a nice circular round, completely clear. And here you have the ballooning process of platelets that we see in AIDS, but not only in AIDS, you're going to see here as well. Again, here is the waste product, okay, what we call the conglomerate. So, normal red blood cells. Not a very hard quantity here of we don't see much somatids. We see them, but not that much. Okay, we see platelets. I don't very well hear your question. Can you just say it a little bit? Mr. Naessens would say 0 degree, because this blood analysis is not made to make a diagnosis. It can bring correlation with different, what he's saying to you right now, because it's what he has observed with his numerous correlation he has brought. But this test, if you see a normal thing, you're going to know like 2 years in advance that the immune system, the natural defenses are weak. But you cannot tell if the person is going to get a cancer, lupus, multiple sclerosis, or any type of degenerative disease. So it's not a specific diagnosed test. It's more to measure the strength of the natural defenses of the body. Does it answer your question? Ok, allez, on est mieux de tout arrêter, là? On est mieux de tout arrêter parce qu'il faut que je... Okay, so you're not too tired? Do you want a 1-minute break to just walk around and just to... Because I'm sure that it's 1 hour and a half, that's just a little... a 3-minute break. You have to understand that the somatide is not the cause of a disease, it is the witness of something that happens in the body. It's a different way of, it means that when the somatides evaluate into different form, different part of the cycle, either the bacterial or the mycelium form, it is a witness that something has been happening in the body. Okay? But we have to understand that it's progressive. If you look into a live blood test and you see phases between 13, 14, ascospore, or let's say a mycelium form, this is because previously the blood had been in a situation where there was a lot of bacterial form. Okay? We don't necessarily see all of them in one time when you look into a blood. So if you see a mycelium form, is that you have to remember that this process has been occurring in the body for a while, and the bacterial form has evolved into something else. Okay? But even with, let's say, an ascospore, later, we've seen it earlier, even with ascospore all around, which means the phase 13, a highly evaluated macrocycle, almost at the end of its cycle, you can still see a few bacterial forms. Okay, it's not necessarily a problem, but again, I would say that the research work to be done from now for the next, I would say, 100 years, if we want to understand the disease and the reaction of the body, is to understand better the blood inhibitors. Because blood inhibitors are really very, very delicate. It takes slight changes. And for an experience, I'm going to recall a story or something that Mr. Naessens did recently with people from France, researcher from a cancer hospital. He took a patient that had, let's say, ascospore, let's say that had a typical blood of cancer. She had lung cancer. And there was a counselor, psychological counselor, that worked out with this patient for a few hours on whatever subject, okay, with a very specific technique. He had her laugh, he had her do anything, he had her to see the cancer as something very different than the disease that would bring her life away. And right before this counseling session, we took a picture of her blood. 2 hours after, we took a picture of her blood without no product, nothing else than communication with a counselor. And after 2 hours, the blood had a completely different picture, with a lot of eosinophil and different things that meant that the immune system was starting to pick up. So all this to say that blood inhibitors are very, very touchy and can be influenced by many things and combinations of different elements, which are not necessarily easy to isolate. Again, I just want also to make clear that to Mr. Naessens' opinion, cancer is I would say, the terminal situation of a generalized disease. The whole body is sick, and at the end of this process, it's going to localize in the weakest organ in the body. Whereas the orthodox way of seeing things, cancer is a local disease that you have to prevent from spreading. So to his opinion, if you take out an organ, okay, or whatever organ or something, he's not saying not to do it. Sometimes you have to do it, because if you don't take out either a mass or something, the person is going to die from it because he can't breathe or something. But if you can do without, it's not because you take out the organ that it's going to necessarily mean that everything is cleaned up, because one anarchic cell can just leave this sick organ and start to run around into the lymphatic system and start a new cycle again. And this probably explains, it takes, to his opinion, it might take up to 5 years that one anarchic cell starts to run around into the lymphatic system to go and start a new system in another organ. So this is just about the time, what we call the remission time, that the Orthodox sees as 5 years. Okay? So I think this needed to be clarified, and I'm sure you understand the difference. So now we're going to keep on with the video. What you're going to see next is a picture not with the somatoscope, but what can you expect to see if you're a health professional working with a microscope with the Naessens condenser. For the purpose of the conference, we took like different slides that we put on a normal optic microscope. You're going to see what you would see on a normal light, not a dark field, like, how do you call that?
Bright field.
Bright field. Thank you. A bright field microscope, and we're going to keep the same slide at the same place, and we're going to switch with the condenser. So you will see pictures, the comparison of what we can expect or what normal microscopy can see with the condenser, just to give you an idea. So we can go on with the video.
La lumière, s'il te plaît.
We will have, faut reculer, hein, parce que là,
Attends, va.
on vient de manquer le...
Ça fait rien, le prochain.
We will have to bring the light down because it's a little bit hard to see.
OK. Light.
Okay. Can someone... Okay, thank you. On peut pas le faire reculer du tout, du tout?
Ah, si. Ouais.
Oui, ça serait parfait, ça. OK. So just watch. Il n'est pas trop vite, là. Qu'est-ce qui arrive? Qu'est-ce qui arrive? Little technical adjustment here. Qu'est-ce que c'est, ça? Ah, c'est the end of the other one? It has backed up further, okay.
OK. Now.
Okay, so look at this slide with normal optic bright field. This is what you can see with the condenser. This is another slide. He's going to adjust the light. This is not with the somatoscope. This is with the condenser.
This. La différence entre le bright field.
This is dark field. Look at this one.
C'est trop vite, c'est ça l'affaire. On ne voit pas la différence.
C'est beaucoup trop vite. Y en a-t-il un autre?
Oui. Là. Il ne reste pas si longtemps. C'est la même image qu'on reprend deux fois.
The same picture that's taken with two different...
Je vais essayer de reculer un peu.
He's going to back it up just to